Okay, everyone. When I was young, I always asked my mom who the most handsome soccer player in the world was. My mom told me it was David Beckham. And do you know, I think David Beckham is maybe the most popular soccer player in America. Do you know why David Beckham can always make a great and quick decision when facing the defense or goalkeeper? And do you have an idea why snooker players like Ding Junhui can always make a precise shot during the game? And why do you think Kobe Bryant can keep scoring and get 81 points in a single game? I believe the answer is that they can master math skills well. I'm a science student in high school and focus my study on math, so I clearly know how to interpret sports games from the point of math. So today, I think everyone has watched sports games before, and we are often fascinated by the distinguished judgment of players during the game. But why can't we become a professional? Today I'm going to talk about this problem, about how to apply math skills into sports with two examples. The first is in a snooker game. He's very handsome, right? Okay, here's the snooker table, and here we need to use our whiteboard to hit the red ball, which is also called a target ball. Otherwise, we will lose our points. We will lose the score. But you know, here the rules between the white ball and our target ball is blocked by the black ball, which we can call the blocking ball. So we should find a point on the table edge to reflect the white ball and make the white ball hit the target ball. We call that point the proper point of reflection. But the problem is how to locate that point. Here, according to the law of reflection, the angle of incidence equals the angle of reflection. I think some of you don't understand what is incidence and reflection. Look, here comes a ray. Before the ray touches the plane mirror, this is called an incident ray, means the rays that coming in. And this is the reflected ray, means the rays going out. So in this situation, the angle of incidence, this angle equals the angle of reflection. So by knowing this knowledge, so now we need to find a point here that makes the angle 1 and angle 2 equal, because that's the situation that reflection can happen. But how to find this point? This is the whiteboard. We can make a symmetrical whiteboard. Actually, it doesn't exist, but we can imagine it exists. It's symmetrical. I think most of us know what symmetrical means. It's a symmetry, like you look into a mirror. So we connect the symmetrical whiteboard to our target board. And this line we get the point A. I believe the point A is the proper point of reflection. But how to prove it? Look, and if we want to prove the point A is the point we want, we have to prove the angle 1 equals angle 2. But how to prove the angle 1 and 2 are equal? The whiteboard and symmetrical whiteboard, they are in symmetry. So the angle 1 equals angle 3. So I think it's very obvious. And angle 2 equals angle 3. I think it's also very obvious. So because angle 1 equals angle 3 and angle 2 equals angle 3, so angle 1 equals angle 2. So the point A is what we want. Understand?
Yeah.
Yes. Oh, thank you. The next example I want to talk about is in a soccer game. Look at this picture. player 1 and player 2, who do you think is more likely to make a goal?
A.
No, it depends on the player
Two.
actually.
Two.
No, really.
Based
Okay.
on the picture.
Two or both?
Two.
The same. One.
Same.
I think one.
One.
Okay.
I don't know.
I can. In some ways, the angle of sight. This is the angle of sight. Means this is a goal post. The two goal posts and the angle in the when you look at the two goal posts, it's called the angle of sight. In some ways, the angle of sight indicates the probability of scoring. The problem is, if we find a place which can provide the biggest angle of sight, that means this place is the best location to shoot because we have the most probability of scoring. But the problem is how to find this location. Okay, here we need some supplemental knowledge. Here's the cycle. Here's the circle. The point A and point B are fixed points on the circle, and point C refers to any other point on the circle, where point D is any point outside the circle. So, according to the features of the circle, we have a result. So the angle 2 is always smaller than angle 1. Angle 2 is the angle ADB, means the D is outside the circle. Everyone, please pay attention to this knowledge because that's what we need to solve our soccer problem. Please pay attention. Angle 2 is smaller than angle 1. Okay, back to our situation. We can make up a hypothetical circle here, and it passes through the two goalposts, and it's tangent to a line L. I think you know what it means tangent. It has only one common point, and it's point C. And point C is only intersection points between the line L and the circle. And it also means any other points on line L is outside the circle, right? Any other point outside line L is such as D and E is outside the circle. So according to what we have discussed in the last slide,
It's the same.
yeah, because point D and point E is outside the circle and C is on the circle. So the point 1 is smaller than point 3, and point 2 is also smaller than point 3. And we can draw a conclusion that angle 1 is smaller than angle 3, and angle 2 is smaller than angle 3. So angle 3 is the biggest angle which can form on a line. So So the point C is the best location to shoot because it provides the biggest angle. Okay. I think in summary, sports games are not just a competition about our body, and it's also a game of our mind. We can find math knowledge quite useful in some circumstances. I believe if we can master math skills well, maybe one day we can become a professional with a lot of fans running behind. Thank you very much.